Hey guys, it's Andre from High Performance Academy. Welcome along to this week's webinar. And this week we're going to be looking at what your options are when it comes to choosing an intercooler for your build. We're going to be talking about the differences between air-to-air, water-to-air intercoolers, also the different types of intercooler cores such as bar and plate versus tube and fin. A few other considerations there as well. We're going to get deep into the pros and cons of those different options. Before we get into that though, just a few updates on what's been going on over the last week. And if you have been following us over the last few pre-shows, then you'll know that I've been talking all about our old engine out of our Toyota 86 endurance car, the one that we now have a couple of inspection ports on the side of the block, and the options that we're going through with selecting a new build. And I actually want to start by apologizing because those who followed our build, our pre-show last week, I went through some of the specifications and the options that we're looking with in terms of trying to get some more capacity out of the engine. And this is why you shouldn't do math with no sleep. As a couple of you quite rightly picked up, I made a dog's breakfast of the stroke calculations, so I do want to apologize. Fortunately, I wasn't sending those instructions straight to our machinist, or we would have ended up in a pretty dire circumstance. However, what it came down to was the idea behind offset grinding the 1UZ or 3UZ crankshaft in order to get a little bit of additional stroke. Basically, we've got a 3UZ FE, which is a 4.3 litre Toyota V8, and we want to get a little bit more capacity out of that without going to the extent of a custom crankshaft. So we did entertain the idea of offset grinding the crankshaft. We looked at the quite common Honda big end bearing size and what we could do with that. The problem with it is, just talking to the company Hartley Race Engines in Palmerston, North New Zealand here, who actually built our original engine that was in the car when we purchased it. They've actually gone down this path some way as well. They kind of specialise in the 1UZ FE engines along with a few others, and they found that offset grinding the crankshaft too far resulted in too much weakness and the crankshaft broke. So that was kind of a problem for us because we've already got a reliability issue with this existing engine. We obviously want to rebuild the engine with the intent of making it as bulletproof as we can. So trying to build in a potential weakness is obviously not something we're too interested in. We did briefly entertain the idea of a custom billet crankshaft, but this is problematic in that it's incredibly expensive, and then if we have a problem with a custom crankshaft, it puts us out of racing for a fairly long time while we get a new one built. So we wanted to keep it simple. Talking a little bit more detail to Nelson from Hartley Race Engines over the last week, we came to the conclusion that we can actually offset grind the crankshaft. There's just a limit on how far we can go to keep everything reliable. Essentially, they've recommended in their own experience 2-inch on the big end journal actually works out pretty well. Now that size needs to be chosen carefully. You can't just choose any size for your big end journals that you want, because we're not in a position where we can go to a bearing manufacturer like King or ACL and have custom bearings made. We really want to select that bearing or the journal diameter carefully so that we can use an existing big end journal or big end bearing off another model of engine. So that's what they've done there. I actually can't tell you off the top of my head what that journal size actually allows us to use. It is, I've said 2-inch, it's actually very marginally larger than 2-inch, but that's where we get to. On top of that, with the 3UZ FE block, we can go to a 1mm oversize. So generally when you are rebuilding an engine or you're building a performance engine, fitting some aftermarket forged pistons, what we will typically do is go to what is called a first oversize. This is 20,000ths of an inch or half a mil larger in bore diameter. That's pretty common. We can't do this in every instance because obviously we are removing material from the sleeve or liner in the block, and the more material we remove, the thinner that sleeve ends up, and obviously we can get into problems with mechanical strength of the engine block if we go too far. Again, they've proven 1mm for a naturally aspirated application is sound, and I just want to add in here, because I know someone in the comments is probably going to pick up the fact that the 3UZ 1UZ blocks are known to be weaker than the 1UZ. Comes down to the larger bore diameter. This really isn't a consideration for us just because we are staying naturally aspirated. Absolutely, if we are running a forced induction engine, it's been proven time and time again that the smaller capacity 1UZ block is the superior option. But in our case, naturally aspirated cylinder pressures aren't going to be anything what you'd see in a boosted application. So we're comfortable with doing that. And again, just to reiterate from our last pre-show, we don't want to go to custom sleeve options. There's a lot of work and a lot of cost involved in that. And again, sometimes you can fix one problem and create another. So that's where we're going. And I won't go through the calculations this time just to get pulled up. But that gives us something, I think off the top of my head, if I remember correctly now, we're just a touch under 4.5 litres. So not a massive capacity increase over the 4.3, but as I said in our last pre-show, all things being equal, if we can keep the same power to capacity ratio for every 100 cc's we gain, we're picking up around about, I think it's about 10 or maybe 11 horsepower. So we'll take everything we can get when we want to get more power out of that engine. We're going to be using this offset ground crankshaft along with some custom rods and a set of custom forged JE pistons. What we're going to be trying to do with those pistons is get as much weight out of the piston as we can. We want to keep everything nice and light because we still intend to be spinning this engine over to about 9,000 RPM. The heads aren't going to be anything particularly unusual here. Again, Hartleys have had a lot of experience with these 1UZ engines in their stock car engine program. That's basically what they're designed for and built for. They have a CNC head porting program, and we're just going to run with that with a set of 1mm oversized Super Tech valves. One issue, again, I'm still following up on this, but it seems like we might struggle to fit a double valve spring into the cylinder head, so we are going to be stuck with a single valve spring. One of the things we're going to be doing as well is trying to remove some weight from the valve train. It might only seem minor, but one of the things we will change to is a titanium retainer just to get a little bit of mass out of there. And looking at our photos of our carnage, Nelson from Hartleys also came to the same conclusion that we had, that chances are it's probably dropped a valve, particularly with the stock pistons that these engines were built with. Then as soon as you drop the valve destroys the fairly brittle cast piston, and the rest is history, as we've already seen. And one thing we will be adding with this engine as well is a set of individual throttle bodies. The engine we've got at the moment runs a single plenum, and it's actually modified and has also started to crack, which isn't that ideal. Basically what it does is it runs a custom lower plenum chamber that's folded up from aluminium and welded, and then the upper section is a Holley EFI LS intake plenum running the LS drive-by-wire throttle body. So because one of the reasons that we want to do this, because the lower part of that plenum chamber has actually started to crack. A lot of this associated with the terrible vibration we had from our unbalanced drive shaft when we first swapped to our TTI gearbox. However, we do want to do some back-to-back testing and see where we get to with a set of individual throttle bodies. So again, this is something that Nelson from Hartleys is working on with us. There's been a fair bit of demand for an ITB kit for the 1UZ, 2UZ, 3UZ engines, and he's got a design. So we'll jump across to my laptop screen. This is basically what we're looking at. This is actually for their custom V12 engine, but you can see the throttle bodies there, billet machine out of CNC, and basically it's just a simple case of taking one part and replicating it for as many throttle bodies as you need. The trickier part is in the lower part here, which is going to bolt obviously to the cylinder heads and incorporate our injectors, and they're actually using additive manufacturing for this rather than building this out of a billet piece of aluminium, so this helps keep the cost down. So this is an idea of what it looks like installed. Again, this is on their bespoke V12 based on the Toyota Century V12, but not a lot of factory parts left on it. We are going to want to retain drive-by-wire, and there are a few problems when we do this. So we had originally looked at a BMW actuator of some of their V8 and V10 engines, which sits down in the valley and uses pushrod actuation. However, Hartleys have had some problems with those actuators not being up to task. So this is a pair of Gen V drive-by-wire actuators here on the end of the throttle bodies. We're going to try that, going down that path and see exactly how that works out. So pretty excited to get the ball rolling with that. Hopefully we will have that engine back up and running in the next couple of months. Obviously there is a fair bit of work to do, and we're going to be waiting on some custom parts out of the US for this. Now, for those of you who are devout followers of High Performance Academy on Facebook, you may have noticed a little while ago we put up a post, and we'll jump across to my laptop screen again for a moment, where we were asking for some suggestions of what our followers would build, essentially with an unlimited budget, with the goal of beating factory-built GT3 Porsches, Ferraris, Audi R8s, etc. in a 3-hour endurance race. And we had a few caveats there, things we needed to take into account. The horsepower level, we're aiming for somewhere in the region of 600 to 800 horsepower. We need aftermarket parts support, particularly around the bodywork and the aero. We want something that's going to be appealing to our followers, and we want something that's going to be nice and light. We had a huge amount of engagement on that, 545 comments, some great solutions, some ridiculous ones as well, as you'd expect. Now, this wasn't just an off-the-cuff comment, because here at HPA Labs, we have been putting our heads together over the last 6 to 12 months, thinking of what we're going to build as a successor to our GT86 with the Toyota V8. That car, again, as those of you who have been following for a while will know, we inherited that off a customer. It's not something we built, and while it's a great fun car, it's undoubtedly pretty quick and somewhat competitive in our class. Probably if we were starting with a clean sheet of paper, it's probably not what we would build. One of the issues is that that engine probably will never produce the sort of power that we'll need to be class competitive, and we also need to do a lot of work to the chassis, the bodywork, in order to get bigger tyres under it in order to create the grip that we need. So rather than going and spending a huge amount of money on that car, we've decided that we're going to leave that. We're going to continue our development, basically get the new engine built, tidy up a few of the loose ends that we'd been chasing over last season, hopefully get it to a point where the axles in the rear are reliable. That'd be nice so we can finish the race, and we're going to run that for our next season of the Endurance Championship. But we know that we're never going to win in that car, so we're looking at options for a new build. And of course, we need something that's going to be interesting for our followers so we can create some compelling content around it. And one of the issues which we highlighted there is that we really need something where we can purchase off-the-shelf bodywork and aero components so that we don't need to develop that ourselves. The reason for this is, for us, that's not our main aim. We are not aerodynamicists. We're also not composites engineers. So we'd rather leave that to professionals who do that every day and basically focus on what we're good at. The problem with this as well is, well, yes, we can engage a company such as maybe Andrew Brilliant from A&B Aero to come over, scan the car and develop the bodywork. It still actually needs to be built. And then we're in a situation where we need to be able to stock spare parts, etc., so that if we do end up having an accident or something of that nature, we can replace the damaged parts. So not the way we wanted to go down. So this is still a work in progress, but let's have a look at the option that's currently sitting pretty close to the top of our list. We'll head across to my laptop screen. Not maybe something that we thought we'd be looking at, but this is a Honda S2000. Now, the S2000 as a chassis probably has a lot of pluses going for it. It is light, it's relatively aerodynamic, and also it has an engine that's fitted basically behind the front axle line, so the weight distribution on it's pretty good straight off the showroom floor. On top of that, though, as we can see here, this is the Voltex bodywork aero kit that was developed, I think, for Evasive Motorsport in the US. And I mean, it's pretty attractive. It increases the wheel track so we can fit wider tyres in there. It is developed with the intention of not just being a show car, though. It does actually produce downforce. So that's obviously the most important thing for us. We want something that's going to look good, but also be effective. We've actually gone as far as already getting a mock-up of what this car might look like, and the branding on the side of that is Earnest Workwear, so that's actually another sister company that we're involved with. This is a company that manufactures workwear, fabrication clothing, mechanics, overalls, etc. So we're going to use this car as a promotional platform for that particular business. So that's the car, and I'm guessing that a few of you are wondering, what are we thinking? Just hold fire because we haven't decided definitively that the S2000 is the platform. If you've got comments or any reasons why we shouldn't go that way, we'd definitely be keen to hear. Likewise, if you've got any better solutions, then please feel free to let us know in the comments as well. Now, the engine is obviously the other component that's going to be key to this project. We want a light chassis, we want good weight distribution, we want to be able to have good aerodynamic downforce, low drag, and of course a decent size tyre front and rear, but it's the power plant that we really need to consider. Now, in the 3R Endurance Championship here in New Zealand right now, we have unrestricted GT3 cars. Last year, the championship, off the top of my head, was won by an Audi R8 LMS GT3 car in unrestricted form, producing around about 650 horsepower. And it is no mean feat, first of all, competing and expecting to beat a factory-built race car. And of course, the guys that are pedaling that car around the track are probably a little bit more experienced and a little bit more professional than Ben and myself. But hey, we can dream, can't we? So in order to give ourselves the best opportunity, we have been thinking about the types of engine combination that would work in this car. The obvious one would be something along the lines of the factory F20C, maybe turbocharged, or we could go K20, K24, again with a turbo setup. It shouldn't be too difficult to reliably produce around about 600 horsepower from a K24 turbo combination. Remembering here that might be sounding like quite a low power level for a K24 with a properly sized turbo. A couple of caveats here. In order to reduce our fuel burn, which is really important over a 3R Enduro, we do need to really be running on pump gas. So we are octane limited on the pump gas. Also, while there's numerous examples of K-series engines with turbochargers producing 800 to 1,000 horsepower or more, we also need to be able to do that for 3 hours. So engine reliability and heat management is a consideration. So while we're sort of going down this path, I was chatting to a friend of mine who builds race cars over here in New Zealand. He's currently building a Ferrari 458 GT3 race car to actually run in the North Island version of our same championship. With a bit of a twist, he's actually put a Ilmor IndyCar V8 engine in it. So that got us thinking. So again, we'll jump over and have a look at this particular engine. So this is a 2002 era 3.5 litre V8 used in the naturally aspirated IndyCar era. Produces somewhere around about 700 horsepower at 10,900 RPM. So on face value, probably a pretty good combination. Total weight for the engine dressed is around about 130 kgs, depending on what source you want to take your data from. There are a couple of problems for us though. Of course, the IndyCar series runs on alcohol fuel, specifically methanol. So methanol is completely banned for Motorsport New Zealand events. We can run E85, but again, it comes down to our fuel burn. So probably it would be fair to say that we would need to reduce the compression and probably give away a little bit of horsepower. But there are some advantages to the simplicity, I guess you could put it, of a naturally aspirated engine over a turbocharged engine. Some disadvantages as well. We've got a lot more control over the power delivery with a turbocharger than we have with a naturally aspirated engine based on the boost pressure that we choose to run. So this is something we are still seriously considering. The only problem that we've struck, other than getting hold of one of these engines, if you're thinking that this looks like a $100,000 plus engine, you actually be quite surprised. These are quite dated now, and there are numerous examples of these engines going somewhere in the region of 10 to 20,000 US dollars, depending on the condition, or whether it needs a full refresh or whether it's dyno fresh. So it's actually, in terms of a race engine, relatively affordable. Problem with this engine is, unfortunately, it's incredibly wide, and the specifications we've got on it at the moment, it's not actually going to fit between the chassis rails of the S2000. So again, we're only spitballing here. This is kind of hopes and dreams sort of stuff, probably the sort of ideas that a lot of you out there, when you're thinking about project cars, come up with some harebrained schemes, some things that would be really cool, undoubtedly incredibly fast, and then at some point reality strikes and you sort of have to pull your ideas back down a notch or two and there'd definitely be nothing wrong with us running the K24 turbo engine. That's going to definitely be a pretty potent combination. However, talking to my friend who runs Mitchell Race Extreme in Auckland, he builds race car chassis, and he was involved in building the control chassis for the New Zealand V8 TLX race car series. It's basically a tin top race series where there is a one control chassis, you put your own body on top of that and whatever engine for that car manufacturer. So I've basically got a front clip that was used for that tube chassis, which looks a little bit like this. We'll head over to my laptop screen again. So this is kind of the chassis rails coming out. It's all a sort of bolt on or weld on section, so it's easy to replace. You can kind of see what it looks like there. In these cars, this was a double wishbone suspension system. Again, there's some advantages here because all of these parts are available direct from Mitchell Race Extreme. So in terms of the upper and lower wishbones, blade style adjustable anti-roll bar, hubs, etc. And talking about hubs, this is a fabricated laser cut hub assembly that is designed and developed for these cars as well. Again, bearings, brakes, everything is available for these and relatively cost effective rather than us trying to reinvent the wheel and do everything again. So this would give us the width across the chassis rails in order to basically fit that Indy V8 if we decide to go that way. If any of you are also thinking that maybe the S2000 not potentially the best option because it is a convertible in stock form. Granted, in stock form, a convertible, it's really hard to get the rigidity into the chassis that we'd see with a conventional car that includes a roof. Now, there could be some arguments both ways. The reality is, talking to a couple of the fabricators that I deal with on a day-to-day basis, basically by the time we've got an extensive roll cage into that chassis with multiple pickup points, particularly running all the way through to the forward and rear suspension pickup points, the difference in torsional rigidity, stiffness of the chassis basically is going to be a moot point. So we don't think that that's going to be a huge problem for us. So there you go. There's a bit of a rundown on what we are thinking about at the moment. Again, it's all up in the air. We do love to dream. Some of our dreams might come to reality, some may not. But again, if you've got any comments on any of that, please let us know. Certainly think it would be pretty cool to have a V8 IndyCar engine revving out to basically 11,000 RPM sitting in an S2000. And this kind of comes back to the angle we were looking at a couple of weeks ago where we were considering the likes of a Judd V8 for our Toyota 86 as well. So obviously we've got a bit of a passion for high revving V8s and V10s. Anyway, moving on, we have just released our latest video today on HPA's YouTube. So I'll jump over to my laptop screen, have a look at that. So this is one that we shot when we were at World Time Attack last year over in Australia. This is the Tilton Evo. This is a car that was built in something like about 4 weeks. And more than the Evo though, we're actually talking to the brains behind the wiring harness construction. So this is 12 Volt Performance who build the wiring harness for the Tilton Evo, as well as there were some shots in there earlier of the wiring harness on Colin Wilshire's Mitsubishi Eclipse, which off the top of my head, could be wrong here, I think it's still the fastest 4-cylinder in the world. So we have a chat with Chris from 12 Volt, find out how he got into motorsport wiring and some of the considerations when it comes to building a reliable motorsport wiring harness. So if you're interested in learning a little bit more about that, head over to our YouTube channel if you're not already there. Make sure you subscribe to our YouTube channel. Give us a thumbs up on that video if you like it, and if you've got any questions, please ask. And also another video release we've just had while we are on my laptop screen. This is one that we've released for our Racecraft sister company, which is a question we quite often get asked. How do we go about optimizing our camber and our tyre pressures? So in this video, we look at how we can use a tyre pyrometer in order to help measure our tyre temperatures. And by measuring the tread temperature, this is going to give us some insight into how hard the tyre is working when it's out on the racetrack. And from here we can decide on changes to our camber as well as our tyre pressure in order to optimize that. So the sort of equipment that we use to do this, I've just got one here. We'll have a look under our overhead camera here, and this is an Alfano Tyre Control PT. So it does a couple of things here. I'll just turn it on for the purposes of this little look. It's obviously got a little probe here we can use to check the pressure of our tyres. It's also got this little K-type thermocouple which which we can insert into the tread, and it's actually going to measure the temperature below the tread. One of the advantages with the Alfano Tyre Control PT is that getting all of these measurements takes a bit of time, and what we can actually do is basically take our recordings automatically, work our way around the car, getting our tyre pressure and our tyre temperatures, store all of those. We don't need to think about them at the time, and that allows us to get all the tyre temperatures in particular while the tyres are still at operating temperature. Then we can stop and we can analyse all that data at our leisure back in the pits while the driver's out, maybe on a cool down lap, and we can decide on what to do based on that data. So yeah, again, if you are interested in learning a little bit more about that, head over to Racecraft HQ's YouTube channel. We're relatively new. Give us a follow there, subscribe to our YouTube channel, and again, if you like that video, give us a thumbs up. If you've got any questions on it, please ask those on the video. Lastly, for today, we are running our AIM Sport data logger giveaway still. So 2 days left to go, I think. So last chance to get in the draw. So this is an AIM Solo 2 DL from AIM Sport. So this is a portable data logger unit. It allows you to basically quickly stick it into your car. You can mount it to the windscreen with a suction cup. Alternatively, you can mount it straight to your roll cage. The advantage with it is that it can be completely self-contained. So it's battery powered. It uses GPS for lap timing as well as track mapping. You can then download all of the data after a session out on the racetrack via Wi-Fi straight onto your laptop. So really, really easy to use. The DL version of this, the one that we're actually giving away, also allows you to connect to either a factory or a standalone ECU via a simple 2-wire CAN bus. And this then allows you to integrate all of the ECU data. So this really greatly increases your ability to analyze the performance of the car as well as the driver. So we're giving that away. Off the top of my head, I think this package is valued at about $900 US. Don't quote me on it. We're also going to be giving away our Racecraft Motorsport Wheel Alignment Fundamentals course and some gold membership to Racecraft. So you're going to get access to our regular weekly members webinars as well as our private members only forum. So I'll get the team to drop a link into the chat that you can follow if you want to get involved. Remember, there is only 2 days left to get into that draw. We'll ship this anywhere in the world, so don't think that you're going to miss out if you're not maybe in the US or maybe you're not right here in New Zealand. We will ship it wherever you are. There are also a couple of tasks that you will be able to complete when you go through and enter there. That'll give you a few more entries into the draw just to up your chances of winning. So go on, get involved in that. You never know, it could be your lucky day. Alright, thanks for watching our pre-show there. Give me a few moments and we'll get started with today's webinar.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.